Hello everyone, and welcome to another math video. So today we'll be tackling the last two sections in Module 4, 1.6 and 1.7. So this section 1.6 focuses on other equations of the quadratic type and also ones with absolute values, and then 1.7 focuses more on inequalities. So let's just get started and work through this. Remember, our three techniques for solving quadratics are going to be quite handy here. Square root principle, factoring, and either completing the square or the quadratic formula. So you can see the 1.5 video for those. This first one, we have something that looks like 3x to the fourth minus 48x squared. And I would call this equation of the quadratic type because we have x squared appearing twice, and the power of the larger coefficient is double that of the smaller one. So what we can do is, they do it just by directly factoring, but I'd like to make a variable substitution just to make it more clear. So let's say let y equal x squared, and then let's see what the equation turns into. Also note if y equals x squared, then if you square y to the second power will be x squared squared, which is x to the fourth power. So the degree 4 equation in x will become a degree 2 equation in y, just a quadratic. So we'll have 3y squared minus 48y equals 0. And then we can solve this just like normal. So first factor out a y. Actually, a 3y will work. 3y, and then we get y minus 16 equals 0. And then set each one equal to 0 and solve. 3y equals 0, or y equals 16. Y minus 16 equals 0, excuse me, but that's the same thing as y equals 16. And then we just want to replace y for x squared once we solve for y. So here this implies y equals 0. So each one we're just going to replace y by x squared. So x squared equals 0. Well, that just means that x equals 0. Or here, if we have y squared equals 16, the square root property will tell us that, this is x squared equals 16 because we turn y into x squared. Then we get x equals plus or minus 4 because x will equal plus or minus the square root of 16. So for this problem, the solution set would be the three numbers 0, negative 4, and positive 4, in no real special order. Okay, let's go down to the next one. Generally, when you have a degree 3, you just need to try whatever you can, but first let's move the 12x and the 8 to the other side. I always like it where I get all my variables on one side if I plan on factoring. So we have 3x cubed plus 2x squared, and then the 12x comes over and becomes a minus 12x. Positive 8 comes over and becomes minus 8. Really, I'm just subtracting 12x and subtracting 8 from both sides, but if you've done it enough times, you realize if you move one thing to the other side, it just changes signs. So let's try factoring by grouping. Whenever we have 4 terms, that's always a good thing to try. So let's just group the first 2, group the second 2, and see if we can get the same binomial factor to appear. So we have an x squared we can take out of the first group, and we'll be left with a 3x plus 2. Okay, so if we want the same factor to appear, if everything's positive here, basically we need to take out a negative from the second group. And negative 4 looks like it'll leave us with 3x plus 2, which it does. So we factor this into the 2. We have the 3x plus 2 factor on the right, and then the factors in front will appear in the left, right? If you take out 3x plus 2, we'll be left with x squared and minus 4. So we get x squared minus 4 equals 0, and then we have either x squared minus 4 equals 0 or 3x plus 2 equals 0. And what that is just the zero product property. If you have two things that multiply and make 0, one of the two factors has to be 0. So solving these you can do rather quickly. If you need a review, please ask me. But we'll just have x squared equals 4. So the first one will turn out to be x equals plus or minus 2 using the square root principle. And the second one is just a one more step, move the 2 to the other side, so 3x equals negative 2. Or, so divide by 3 now, and we get x equals negative 2 over 3. Again, on my math lab, there's no plus or minus symbol, so you're going to have to write out all the solutions. So here it would be negative 2 over 3, and positive 2. Sometimes they even specify increasing order, so that would be increasing order, because negative 2 is the smallest number, negative 2/3 is the middle, and 2 is the largest. Okay, now we have what are called radical equations. So basically, whenever you have a radical equation, you want to isolate one of the radicals and square both sides. But whenever you square an equation, it's possible to introduce extra solutions. So you're going to need to make sure to actually check your answers. What do I mean, introduce extra solutions? Well, say we just started out with the equation x equals 3, and then we squared both sides. X squared equals 9. Well, the solutions to this are actually twofold. There's two solutions. So x equals negative 3 or positive 3. But the initial equation only has one solution. So whenever you square an equation, basically new solutions can just kind of appear, and it's just because when you square a negative number, you can still get the same value as a positive number. So basically the thing you want to do is whenever you square an equation, just remember to check your answers. So you need to plug them back in to the original equation. So this one, let's start just by squaring both sides. So if you have the square root of 2x plus 13, and you square it, that'll equal x plus 7 squared. So whenever you square something that's underneath a radical, those are inverse operations, so we just get the 2x plus 13. But then on the other side, we need to remember to FOIL. Remember, x plus 7 squared is really x plus 7 times x plus 7. And we need to multiply that out. So we'll have 2x plus 13. This will equal x squared plus 14x plus 49. So let's move the 2x and the 13 from the left side to the right side and combine our terms. So we'll get 14x minus 2x, which gives us plus 12x. Then we'll have 49 minus 13, which gives us positive 36. So then we get 0 equals, and then you can factor this into x plus 6 times x plus 6. So either x plus 6 equals 0 or x plus 6 equals 0. And we get x equals negative 6 as the only solution. But let's check it in the original equation. Does it actually work? Well, in this case, if you plug in, so check. So we need to make sure that the square root of negative 6 times 2 plus 13 does in fact equal negative 6 plus 7. Well, this is just the square root of 1, which is positive 1, and this is positive 1, so the two things are actually equal, so it does check out. Okay, let's keep on moving. What is next? We have a complicated one here. I'm basically going to show you how to do this. There's only one on the homework, and I won't test you on any questions this tough. When you have two square roots like this, added or subtracted, you're basically going to have to square the equation twice. So basically you want to isolate one of the radicals and then square the equation. Hopefully you can isolate the other radical and then square it again. So let's move this term, the minus square root of x minus 8, to the other side. So since we're subtracting it, let's add it. So we get the square root of x minus 5 equals 3 plus the square root of x minus 8. and then we're going to square both sides. So the first, the left-hand side is just going to be x minus 5. Those cancel. But the right-hand side is a little more work. We're actually going to have to FOIL that out. So basically, I'm going to call this step star in parentheses, and we're going to go to another page and work on star and then come back and replace it. So let's go down here and let's try to remember what we were looking at. We have 3 plus the square root of x minus 8 squared. So I just want a little more room for that. So we have 3 plus the square root of x minus 8 squared. So this is really equal to 3 plus the square root of x minus 8 times 3 plus the square root of x minus 8. And so now we need to FOIL this as if there are two terms. So consider 3 one term and the square root part another term. So first what we'll do is we'll multiply 3 times 3. So we do 3 times 3. That's the first terms. The outside terms will be 3 and the square root. So 3 times the square root of x minus 8. Then the inside terms also look like 3 times the square root of x minus 8. And then the last terms will give us square root of x minus 8 times square root x minus 8. So we get 9. And then notice 3 square root x minus 8, 3 square root x minus 8 are like terms, so we can just add the regular numbers. So we get 6 square root x minus 8. And then the last terms are actually square root of x minus 8 times square root of x minus 8, which is the square root of x minus 8 squared. So we'll really just get plus x minus 8. Okay, now we want to look at all the terms that are not underneath a radical, so that would be the 9, the x, and the minus 8, and see if we can combine any of them. Sure enough, 9 and minus 8 go together. And I'm going to move the x in front just for simplicity. So we get 1 plus x plus 6 times the square root of x minus 8. So this is what we're going to replace star by. Okay, so let's go back to the other page. So 1 plus x plus the square root plus 6 times the square root of x minus 8. That is what's going on the right-hand side of this equation. 1 plus x plus 6 times the square root of x minus 8. Okay, so now let's move all the regular numbers to the other side. So we need to subtract 1 and subtract x. Well, guess what? The x's actually cancel when you subtract x. So we're going to get minus 6. And that's going to equal 6 times the square root of x minus 8. Before we square both sides, let's just divide by 6 on each side because that's going to cancel pretty nicely. 6 over 6 goes away and 6 over 6 goes away. So the numbers are a little bit smaller, so we just get negative 1 equals the square root of x minus 8. Now we go ahead and square both sides again. And we get 1 equals x minus 8. Add 8 to both sides, we get 9 is equal to x. So we're done, but we still got to check. So check up here in the original equation, see if this holds. So our check looks like we're checking to see whether the square root of 9 minus 5 minus the square root of 9 minus 8 actually equals 3. And what do we get? We get the square root of 4 minus the square root of 1, which is actually equal to 2 minus 1, which equals 1. So this one does not check. So in this case, no solution, because x equals 9 actually doesn't work. So all that hard work squaring everything, and this doesn't even end up working. Sometimes life's not fair. I know we want to get a solution, but still, the best thing to do is go through the normal process and then see at the end if it works. This case it didn't. That's okay. No solution, still a perfectly fine answer to get. Okay. Um, this one is actually one we kind of touched on when we did the rational exponents, but let's just go through it. We have 6x to the 5 over 2 power minus 12 equals 0. So move the 12 to the other side, and then let's divide by 6 to make the number smaller. So we end up with an equation that looks like x to the 5 over 2 equals 2. Here's one where we actually want to just make sure that we're getting, we remember what to do to isolate x. So how do you undo the 5 over 2 power? Well, basically, whenever you raise a power to a power, we multiply the powers. That's the rule of exponents. So to undo the 5 over 2 power, we have to raise both sides to the 2 over 5 power. So how do we evaluate that? Well, this is just x, and on the right-hand side, this stands for the fifth root. Remember, power on top, root on the bottom of 2 squared. So here our solution set is x equals the fifth root of 4. And that's it. Okay. And the same property applies to any algebraic expression. So to undo a power, you need to raise both sides to the reciprocal power. So here we have x minus 4 to the 2/3 power. So first, we don't want to try and mess around with this. We just want to raise both sides to the 3 over 2 power. And the left-hand side will cancel, and we'll just get x minus 4. And on the right-hand side, we want to think about this as the square root of 16 and then cube it. I'm doing the root first instead of the power because I know the square root is 16. And if I raise it to the 3rd power first, I might not know the square root of that number in my head. So x minus 4 is going to equal 4 to the 3rd power. So we get x minus 4 is equal to 64. Add 4, and we get x equals 68. And you can check that in the initial equation if you want and see that that's actually a correct solution. But yeah. I'm just checking on the other side. So they have a step where they actually introduce a plus or minus. Why are they doing that? I'm looking at this step right here in the similar exercise. I just noticed it. So when they raise both sides to the 3 over 2, they're getting plus or minus. Why are they doing that? Because they're actually taking square roots. If you notice, there is a 2 on the bottom. So on the other one, the root was odd, so we didn't have to do plus or minus. But right here, we did the 3 over 2 step. We actually need to remember to do plus or minus. So we should get a plus or minus this, plus or minus that number, plus or minus this number. So plus or minus this number. So we're actually going to get 2 answers. We're going to get x equals 68, so positive 64 plus 4, or negative 64 plus 4, which gives us x equals negative 60. So we need to check and see if both of these work. And the first one will work if you check it, but I'm going to come over here and show that the second one probably won't. So let's check x equals minus 60. So we'd be looking at negative 60 minus 4 to the 2/3 power. Actually, it looks like it's going to work, because we'll get negative 68 to the 2/3 power. And when you take the 3rd root of negative 68, so I'll do the 3rd root of negative 68 first and then square it. So Sorry, this is where I'm getting confused. Negative 60 minus 4 is negative 64, not negative 68. Please excuse me. That was a silly mistake. All right, so not an 8. That should be a 4 there. So that should be a 4. Negative 64, negative 64. So this will end up being negative 4 raised to the second power, which is still positive 16. So actually, both are solutions. So your solution set would be negative 60, comma 68. Yeah. So yeah, pay attention whenever you're doing this plus or minus 3 over 2. Really remember 2 on the bottom really means a square root, so we need to do plus and minus there. That's actually kind of a subtle point, and it almost escaped me until I looked to the left side of the page. So yeah, always double check your work. That's a good one. Okay, so a few more equations of the quadratic type. For ones like this, again, we have an x squared and an x to the fourth, and I know if I just let y equal x squared, this turns into a quadratic equation. So I get y squared minus 5y plus 4 equals 0, and then solving for y isn't too bad. We just get y minus 4, y minus 1. So we get either y is equal to 4 or y is equal to 1. But remember, it's very tempting to stop right there, but what we need to do is replace y by x squared and actually solve for x. So we have x squared equals 4, or x squared equals 1, so x is equal to plus or minus the square root of 4, which is 2, or x is equal to plus or minus the square root of 1, which is plus or minus 1. So our solution set will be negative 2, negative 1, 1, and 2. Next one looks a little trickier, but the same trick works. Why? Because if we let y equal x to the 1/3, then when you square both sides, y squared will equal x to the 1/3 squared. And squaring that will still just mean multiplying the exponents. So that'll give you y to the 2/3. So if we let y be equal to x to the 1/3, we just get y squared minus y minus 6 equals 0, which we know how to solve with factoring. Y minus 3, y plus 2 equals 0. So this means that y equals 3 or y equals negative 2. And then we change y back into x to the 1/3. And then we just have to raise both sides to the third power. So in the one case, we have x equals 3 times 3 times 3 is 27. Or negative 2 times negative 2 times negative 2 is negative 8. So here our solution set is negative 8, 27. Okay, so absolute value equations. Pretty much the basic thing to think here is whenever we have an algebraic expression, so the absolute value of any algebraic expression equaling a number, there's two possibilities, right? If you have the absolute value of x equals 7, it could be either positive 7 or negative 7. So you get two equations here. The algebraic expression equals the number, or algebraic expression equals the opposite of the number. Okay, so in this one up here, the way we get rid of the absolute values is we actually make two equations. So x minus 2 equals 7, or x minus 2 equals negative 7. And then just solve for x. So add 2, x equals 9, or x equals negative 5. And you're all done. You can check both. If you plug in negative 5, you'll be taking the absolute value of negative 7, which is positive 7. And if you do positive 9, 9 minus 2 is 7. Okay, so a mini kind of word problem here. The formula t equals the square root of d over 2 models a player's hang time t in seconds in terms of the vertical distance d in feet. If hang time is 1.16 seconds, what is the vertical distance of the jump to the nearest tenth of a foot. So I know this one does come up on the homework, so you might want to note that. So they're giving you a value for t, and they want you to find d. So we just plug in 1.16 for t, that's a hang time, and we just need to solve for d. Nothing too spectacular here. So multiply both sides by 2, so we'll get 2 times 1.16 equals the square root of d. So here we'll get 2.32 equals the square root of d, and then we just square both sides to get the distance that he jumped from in feet. So d is going to be 2.32 squared, so let me try and find a calculator. There's one. 2.32 times 2.32 gives me 5 point, and they say to the nearest tenth, which is 1 decimal place. So we just need to do 5.8 or 5.9. 5.4. 3/8 rounds to 5.4. So 5.4 feet. So he jumps a vertical distance of 5.4 feet. Way higher than I could jump, that's for sure. Okay, so that is it for this section.